the triangle inequality theorem. Let's, well, I tell you what, let's forget about what it's saying here. Here's what I want you to think of. You've got 3 sticks. I hand you 3, we'll call them sticks, straight sticks. And they are of length 3 inches, 5 inches, and 10 inches. And I say build a triangle with these 3 sticks. Don't break them, don't bend them, build a triangle. What do you tell me? Possible? Impossible. And you're thinking, well, if you got 3 sticks, all triangles have 3 sides. So obviously it must be possible to build a triangle out of these 3 sticks. Impossible. You can't. The triangle inequality theorem, which is the first thing we're going to do today, says that, you know what, just because something has 3 sides doesn't mean you can put those 3 sides together to build a triangle out of it. Here's how I want you to picture this. Take the longest stick. Lay it down first. It's 10 inches long. Attach one of the sticks to one side and the other stick to the other side. Close the top 2 sides till you form a triangle. That's how you build a triangle, right? One stick, put the other 2 sticks, close it, you got a triangle. Does everybody see the issue here? Can you close it? It's gonna, as you fold these in to build a triangle, they never touch, do they? So let's see what kind of measurements that we're going to need in order to build a triangle. Instead of 5, 3, and 10, let's go for 5, 3, and 7. So now the longest stick is 7 inches. You have a 5-inch stick. You got a 3-inch stick. Can you build a triangle out of that? Sure. What about 5, 3, and 8? Let's change one measurement. Instead of 5, 3, and 7, what about 5, 3, and 8? Can you build a triangle out of that? No. Because what happens? Where does these 2 endpoints hit? On that bottom stick, doesn't it? Can't build a triangle out of that. Let's change one of these. What about 5, 4, and 8? Sure. What about 5, 4, 10? No. What about 7, 4, and 10? Yes. Now, what I want is you to tell me, what does the triangle inequality theorem state? What has to be true about the 3 sides? The longest side has to be what? You said, think about, okay, what has to be the relationship between these 3 sides of this triangle? And it has something to do with that longest side. Think about when this was 6 and 4, when you folded it in. Well, that wasn't okay. What if it was 5 and 4 and you folded it in? That's still not okay. 8 and 4, we're good. What has to be true about the longest side? More than what the other 2 add up to equal. You just, in your own words, stated what this triangle inequality theorem states. The longest side of a triangle has to add up to be bigger than the other 2 sides. Here we go. The sum of the lengths of any 2 sides of a triangle must be greater than the length of the 3rd side. Or what I feel like what you just stated was more accurate. Let's write it like this. If you have a triangle and you have side lengths A, B, and C, to where C is the longest. Okay, that's what we're mostly concerned with. A and B has to add together to be bigger than C. If it's not going to be a triangle. So the next problems we're just doing, same thing I asked you on those last ones, is it possible to form a triangle out of these 3 side lengths, 8, 15, and 17? The one we're most concerned with, 17. And again, what we're doing is we're laying down that stick first. And I want you to picture, every time we work one of these problems, I want you to picture it like this. You have the longest stick down. You have lengths of 8 and 15 also. And the question is, can you close it to form a triangle, or is it going to close before it forms a triangle? What do you think about this one, Claudia? Is that going to be a triangle? Yes. We're okay here. And again, the reason we're okay, if you add 8 and 15 together, you get 23. That's bigger than 17 done. That's all you have to do on this. the two shorter sides has to add together to be bigger than the largest side. 6, 8, and 14. Brianna, triangle, no triangle. No triangle. You lay 14 on the bottom, 6 and 8 on the sides. As you close in 6 and 8, they don't close until they hit the bottom side. 6 plus 8 is 14. Notice that in that inequality, when you add the two together, it has to be greater than. I didn't say greater than or equal to. It has to be bigger than that. In that case, it's equal, so therefore that does not work. Okay, the next set of problems is they say, what does the third side need to be? What if the other two sides are 4 and 8? What does the third side? It could be anywhere from where to where. Okay, let's try this. You've got two scenarios. 8 foot. Is 8 foot the longest side of this triangle? No. It could be. It might not be. First scenario, let's say that 8 foot is the longest side. So we got an 8 foot stick here. We got a 4 foot stick here. And we want to know, what does this side need to be? Second scenario. What if 8 is not the longest side? What if we've got 8 here and we've got 4 here, and the longest side is unknown? I want to know, in these two scenarios, what does the third side have to equal? Destiny, first scenario. We have the longest side being 8. We have a side length of 4. What must be true about question mark in this scenario? Did I say Destiny? Could it be 3? Could it be 3? Could it be 4? Could it be 4.1? Yes. Because if it's 4, if this were 4, as we close it, it's going to close on that bottom side. So it has to be bigger than 4. So I'm going to put here bigger than 4. So it could be 4.1, 4.2, it could be 5, it could be 6, it could be 7, or could it? Let's look at our second scenario. Rachel, we have side lengths of 8 and 4 now. Could this bottom side be, I don't know, 13? Could it? If this were 13 and you started closing these, are they going to form a triangle before they close? No. What if it was 12? Anybody? If the bottom side was 12, would it form a triangle before it closed? No, but they would touch on that 12, wouldn't it? So what do we know about this bottom side? It must be smaller than 12. Because if it was 13, it closed. No triangle. If it was 12, no triangle. If it was 11.9, yes, it would be a triangle. What kind of triangle would it be? If that bottom stick was 11.9, what kind of triangle would you have? I know it's scaling. I know the sides are the same. But according to angles, what kind of triangle do you think it would be? Very obtuse, wouldn't it? Because if this was 11.9, as you close that, this would nearly close before. So you'd have a very flat, obtuse triangle, with this top angle being probably about 170 degrees. So again, I repeat, there is a relationship between the sides of a triangle and the angles of a triangle, a very close relationship. So how do we write this? We need to be bigger than 4, and it needs to be smaller than 12. Let's go back and talk some algebra. The third side of this triangle, and I don't care what you call it, if you want to call it side C, if you want to call it third side, I don't care. But it needs to be bigger than 4. I'm going to say it's x. X, that third side x needs to be bigger than 4. How do I write that? Actually, let's do the smaller than 12 first, because that's pretty easy. X needs to be smaller than 12. Can it be equal to 12? No. X needs to be smaller than 12. And to save paper, because I'm all about saving paper, let's write this as a sandwich statement. You could put x needs to be smaller than 12 and x needs to be bigger than 4. You could write that. That's not. Let's write it as a sandwich. X needs to be smaller than 12 and x needs to be, okay, let's look at that sign. And in all these years, teachers have lied to you. Because all these years, everybody said, oh, that's a less than sign. Guys, you know what? That's not necessarily a less than sign. It all depends on what order you read it in. If you're reading from left to right, yes, that is something is less than x. But if you're reading this thing from right to left, doesn't the, y'all remember the whole alligator thing? Right? Doesn't the alligator always eat the biggest one? So if you're reading it backwards, is this not x is bigger? Is it not eating the biggest one? Would x not be the biggest one between whatever x and this one is? X is greater than, okay, go back up there. What does x have to be bigger than? That third side has to be bigger than 4. That's how I want you to write it, as a sandwich. What that sandwich statement says is 4 is smaller than x. Let's read it backwards. X is bigger than 4. And also, x is smaller than 12. So pretty much what does this say? X is between 4 and 12. Could x be 5, 6, 7, 8, 9, 10, 11? Yes. Could x be 4.1 and 11.9? Yes. Could x be 4 and 12? No. So that's the best way to write it. That third side of the triangle can be anything from 4 to 12. Let's try another one. What if you have 5 and 11? Consider both scenarios. We don't know. The second scenario, the longest side might be your x. Jackie? The first one. Tell me something that must be true about x. Well, first off, tell me what x for sure cannot be. What number? It's going to close. 6. If x were 6, and that's kind of your cutoff number. Does that make sense? That's why she gave me that 6 number. That's kind of the cutoff. If x were 6, this thing would close in. You do not have a triangle. But different numbers on each side of 6 gives me good triangles. Jackie, is 7 okay? Is 5 okay? No. So x could be numbers bigger than 6. Let's write it like that. X is bigger than 6. And second scenario. JC, what's my cutoff number? We got 5 and 11 for my sides there. Tell me what x cannot be. Which number? Or 16. Can't be 16 either, can it? If x were 16, it would close in. 5 and 11 give you 16. If x were 16, those sides would close in. You do not have a triangle. 17, she's already said, is not okay either. But what about 15? We're good with 15. So x could be numbers smaller than 16. And the reason we don't say, well, x is 15 down. Well, x could be 15.9. X could actually be 15.99999. Okay? X could be anything smaller than 16. So how do we write that? X is bigger than 6. X is smaller than 16. What we're going to do is we're going to shove these two statements together. X has to be smaller than 16. Isn't that what that says? X has to be bigger than 6. I just flipped it around. And you can read that as x is between 6 and 16. X could be 7, 8, 9, 10, 11, 12, 13, 14, 15. X could be 6.1. X can be 15.9. There is a relationship, and all this is building up to that relationship. That everything that we're doing is building up to the relationship between angles and sides. There is a relationship between the angles and the sides of a triangle. Said that once or twice. The bigger the angle, okay, look at what happens. The bigger you have an angle to be in a triangle, the larger the angle becomes. If you start making this angle bigger and bigger and bigger and bigger, the side that's affected is actually across from it. The biggest side of a triangle will always be across from the biggest angle. Biggest angle across from biggest side. On this one, notice, here's the smallest angle. The smallest angle of a triangle will always be across from the smallest side. Because angles are what gives the sides a length. The bigger you make an angle, the bigger it's going to make the side across from it. So to make a long story short here, the bigger an angle grows, which maybe this will work. Let me see. Watch this. Okay, and I don't know if I can. Yeah, look what I'm doing to that angle over there. I'm wanting the other two to stay set. As I make this angle bigger and bigger, as I make this side bigger, okay, the biggest angle will always be across the biggest side. But let's move it around some. Let me do that. Look where your smallest angle is. Smallest angle here, 26 degrees. Smallest side, hey look, 11.9. The middle angle, 40 degrees. Where's it located? Across from the middle side. The biggest angle will always be across from the longest side. So again, largest angle, largest side, smallest angle, smallest side. That's all we're trying to teach you with this part. And that's all that says. List the angles in order. But they don't give us angles. It's okay. Biggest angle, biggest side, smallest angle, smallest side. Kyle. And I want to make sure y'all know how to name these sides of this triangle still. Kyle, what's the largest side of this triangle? RQ. Everybody sees that the largest side is RQ. So therefore, Vanessa, since the largest side is RQ, what's the largest angle? And let's do this just for extra practice. Somebody name angle P. Actually, Nicole, name angle P something besides angle P. How else could you name it? RPQ or QPR. Okay, order is important. The vertex must be in the middle. So P is the biggest. Megan, what's the smallest side? PR. So Hunter, since PR is the smallest side, what's the smallest angle? Smallest side, so P, this one? PRQ, that'd be this one. Is that the smallest side? No. Since this is the smallest side, your smallest angle would be located here. So PQR. Everybody okay with that? Smallest side is always across from the smallest angle. So therefore, putting these in order from smallest to largest, and I don't care if you count them Q, P, and R, but since that's the only angle that's located at that vertex. So angle Q, then angle R, then angle P. That's in order from smallest to largest. We're good there. Same thing, we won't write these down. Which is, let's say we're ordering these from smallest to largest. Caitlin, which one is the smallest angle? Perfect. Angle B is located across from 3.7. 3.7 is the smallest side. Angle B is going to be the smallest angle. Chris, what's the medium angle? Angle C. Because, again, the medium side is 4.8. So therefore, he's exactly right. C is across from it. So angle A must be the largest because it's across from the largest side. Let's do it backwards now. List these sides, and there's one on your test just like this. List these sides in order from shortest to longest. But we don't have all our angles. I'm able to test you on two different things with this problem. First thing you need to know, well, they have to add it to 180, right? So in order to do this, we need that third angle. 45/56 is 101. I believe that leaves 79 degrees for the third angle. Okay, I need that. So Erica, I need the shortest side. In order to find the shortest side, what I'd first do is find the smallest angle. Erica, since G is the smallest angle, what's the shortest side? Perfect. FH is the shortest. Jordan, D, since angle H is the middle angle, what's the middle side? Perfect. So we have FH, FG, and the longest, therefore would have to be GH. Y'all good with that? Need to work another one of those. Word problem. Ben, Gilberto, and Hannah are playing Ultimate. Hannah is trying to decide if she should pass to Ben or Gilberto. Which player should she choose in order to have the shortest pass? Anybody find something odd about this problem? Okay, you're on the field and you're playing Ultimate Frisbee. You don't know who's closer to you. But you do know for some reason the angles between you and the other players on the field. I have no idea why you would have this information, but you do somehow. You know that between Ben and Hannah, Gilberto has a 48-degree angle, and between between Ben and Gilberto, you got a 62-degree angle. If you did the math there, I think you would have, because obviously you have time to do math while playing Ultimate Frisbee, you know that you have a 70-degree angle between the other players. So, which player should she choose? Who's throwing at Hannah? We need to know if this is closer or if this is closer. The shortest angle is across from the smallest side. So therefore, the smallest angle, since this is a 48-degree angle, I would say the pass from Hannah to Ben would be the better pass to make. Any questions? This problem is on your test. And a lot of people on their test, if I'm not mistaken, I think it's on this problem, a lot of people say, well, this one looks like the shortest, so I'm going to put them in this order. Don't go by looks. List the angles and sides of each triangle, or of this triangle, in order from smallest to largest. But you don't have any angles except for the 90. You do know the largest side, though, don't you? In a right triangle, the largest side is called the hypotenuse and is always located across from that 90-degree angle. I believe that would be a corollary. We're not listing it as a corollary. That's something you already know, but now you know why you know it. In a right triangle, you're only going to have one 90-degree angle. And you will never have another angle that's bigger than that 90-degree angle, will you? From what we just did, isn't the largest side always across from the largest angle? In a right triangle, the 90 will always be the biggest. So the hypotenuse will always be located across from it for that reason. 2x plus 1, 2x plus 9. Ethan, if I add those two together, I will get what number? This angle plus this angle will always equal how many degrees? Perfect. And I believe that that was also a corollary. It was a corollary to this fact. In a triangle, the three angles add up to 180. In a right triangle, the two small angles always add up to 90. So from what Ethan said, I believe I have 4 x's. I have plus 10 is 90. Let's solve that in 2 steps. Sydney, let's do it in our head. Our plus 10, let's move it to the right side. What does the 90 become? And we got to divide by this 4, and we get x is perfect. And if x is 20, now I know what my angles are. 41 and 49. Now that I know what my angles are, now I know the angles in order, and I know the sides in order. I'll put the angles in order, since that's the hardest part. Angle X is the smallest. Angle Y is the next smallest, and angle Z is the biggest. That's the angles in order. Now let's put the sides in order. Stephen, help me out with that. If angle X is the smallest, which side is the smallest? Perfect. Go ahead, Stephen, finish for me. Since angle Y is the middle side, then what's the middle, or excuse me, since angle Y is the middle angle, what's the middle side? And that only leaves my hypotenuse, XY, for the largest. Here's another one just like that one. This is not a right triangle, though. As far as I know, I say it's not a right triangle. It could be. It looks actually fairly close to a right triangle. Carson, help me out with the relationship. 2x plus 3, x minus 1, and x plus 6 will have to add up to what? The three angles of a triangle always add up to 180. Abby, help me with my x's. I got 2x, x, and x. How many x's? Good. So 4x, and let's go ahead, and again, I'm all about saving paper. Plus 3, minus 1, and plus 6. If you put those together, I believe you get plus 8. Right? 3 minus 1 is 2. 2 plus 6 is 8. Let's go ahead and move that 8 over here. Abby, if you take 8 from this, because it's plus 8 here, you've got to change to minus 8. What do you have on the right side? Perfect. We divide by 4, and I believe we get x is 43. which makes this a 42-degree angle, a 49-degree angle, and a 86 plus 3 is 89-degree angle. Nearly a right triangle. So will a squared plus b squared equal c squared? Nearly. It'd be close, but it won't. It'd be like a few decimal points off, probably. You could nearly use Pythagorean theorem on this problem. So we know our angles in order. Angle P is the smallest, angle Q is the second smallest, and angle M is the largest. Our sides in order, that's what we're more concerned with. Since this is the smallest angle, Zoe, what's the smallest side? Perfect. And Zoe, go ahead and finish the rest for me. Since 49 is my middle angle, what's going to be the middle side? Perfect. And my largest side obviously would be PQ. Any questions? Next topic. I think we've been there, done that. In a right triangle, again, there's a relationship between legs. And again, we'll find out later on, there's also a relationship between angles and legs. In a right triangle, the same way as in a isosceles triangle, you have two legs. And you have a third instead of a base, we call it a hypotenuse. You have two legs and a hypotenuse. And again, we've talked about it in classes past. I believe you've been having this ever since 5th or 6th grade. The two legs we call A and B. It doesn't matter which is A, it doesn't matter which is B. The hypotenuse we call C. And the relationship between the legs and the hypotenuse of a right triangle, the square of the sum of the two legs will always equal to the square of the hypotenuse. This theorem has been around for thousands of years. I believe Pythagoras being the one that made it famous. Not necessarily the one that discovered it, but the one that made it famous. So, if you have a right triangle that has legs of 6 and 15 and a hypotenuse of x, you can use that relationship in order to find x. The square of the legs, the sum of the square of the legs, will always equal to the square of the hypotenuse. Sierra, help me clean this up. 6 squared, Sierra, is plus 15 squared equals x squared. I'll show all the steps. 36 and 225 is equal to 261 equals x squared. Now let me go first off into a little bit of algebra. To get rid of a square, you do the inverse operation to the other side. If this was plus 1, we do minus 1 over here. If it was minus 1, we do plus 1 over here. If it was times 2, we divide by 2. But since it's square, we take the square root. To get rid of a square, you always square root. But you're leaving something off. When you get to Algebra 2, pre-calculus, and back in Algebra 1, when you get rid of a square, you actually put the positive negative square root. The reason we leave that off, and it kind of stinks that we do leave it off because it gets us into a habit of forgetting it once we get into our other classes. The reason we leave that off is I don't think that x is going to be a negative number. So most of the time when we're dealing with it in geometry, we'll just say square root of 261. There's two different ways to leave that answer. This is all review now. Two different ways to leave this answer. One way is, well, first off, is the square root of 261 exact? It's not, is it? One way to leave our answer is by trying to simplify it, trying to reduce it. Trying to find something that multiplies to give me 261. And actually, I think it might be a prime number. So it might be beating our head against the wall. No, 9 will divide into it, won't it? How in the world do I know 9? Let's see if anybody knows this. How in the world did I just glance at that and say, hey, 9 goes into that? Somebody know the trick for 9? Add them up. Somebody add 2 6 and 1 for me. What do you get? 9. Guess what? Since 9 goes into that, 9 goes into 261. Don't know that trick. So therefore, I can split this into the square root of 9 times the square root of, okay, here's my thought. Don't use your calculator. Everybody do 3 times 9 in their head. 27. Can you do 30 times 9 in your head? 270. 30 times 9 is 270. That's a little bit too high, isn't it? How much too high is it? 9. So instead of having 39s, you have 29 nines. So break it into something that you can take the square root of. I don't know the square root of 261, but I do know the square root of 9. So what I can do, since I know the square root of 9, I mark it out, and in its place I put a 3. 3 root 29. 3 times the square root of 29. That's simplified. That's one way of writing it. By the way, that is equal. The other way of writing it, let me know, approximately. Put the squigglies. The square root of 261 is approximately, let's see, how big? 16 point what? 4? 2? Don't talk so quiet. I don't want to hear your voice on video. It's about 16.2. Now, this is where I review irrational numbers. The reason I have to put the squiggly, it's not equal to 16.2. That is not an exact answer. If you're building a bridge, don't use that answer. It's approximately 16.2. How far out does that answer go? I mean, your calculator has a fairly large screen that holds like 10 numbers, but how far beyond that does it go? 11 or 12 numbers? Forever. Okay, it does not end. Okay, the square root of 261, since it is not a perfect square root, like 16 and 25, is irrational, which means it goes forever, just like pi. There's no pattern. Okay, it could be 1, 5, 9, 3, 8, 2, 7, 4. It's just random digits after that. So therefore, that's the reason we put squiggly equal. It's about 16.2. Any questions? Left.